Hello, today we're going to talk about slope and rate of change. So our essential question, how is slope classified and what are the characteristics of parallel and perpendicular lines? So let's start off with some definitions. Hopefully you've seen this before, but when we're talking about slope, that would be m in the y equals mx plus b equation. The slope of a non-vertical line is the ratio of vertical change to the horizontal change, or as you've probably heard before, the rise over the run. The rate of change is how much one quantity changes on average relative to the other change, or to a change in another quantity. And then you can calculate slope a few different ways. Again, it's the rise over run, the ratio of the horizontal change to the vertical change. So the formula that we use is m equals y2 minus y1 over x2 minus x1. And if we're looking at a graph, if we're given 2 points, we can just calculate what our vertical change is and write it as a ratio to what our horizontal change is. So the first example we're going to look at, what is the slope of the line passing through the points? Just as a reminder, m, or our slope, equals y2 minus y1 over x2 minus x1. So I always like to start these just by taking the first ordered pair, labeling which one is x and y, and because it came first, we'll call it x1 and y1. And then look at the second ordered pair. Because this one came second, we'll call it x2 and y2. So then when we calculate the slope, the values that are written right above those variables, we're just going to substitute in. So we're going to have 7, because that's right above y2, minus 3. We're going to put that over 6 is right above x2, 1 is right above x1, and then we can reduce. So remember order of operations, PEMDAS. I know I can't see a set of parentheses, but when you have a fraction written the way we do here, that's a special type of grouping symbol. So you still want to simplify both the numerator and the denominator first. So when you take 7 minus 3, you get 4, 6 minus 1, you get 5. And you can leave your answer as a fraction, because when you're graphing, it's actually easier to have it left as just a fraction. Don't do decimals. So when we're classifying lines based on the slope, we have 4 different types of slopes we could look at. Generally speaking, you always want to go left to right. The reason I'm saying generally speaking is because we have one case where that's a little bit harder to use that rule. But if you have a positive slope moving left to right, the line should be increasing. If we have a negative slope when we're moving left to right, the line should be decreasing. If we have a zero slope, we have a horizontal line. So anytime you have a horizontal line or a zero slope, you have just horizontal line. It should never ever touch the x-axis. And then we have one other kind of special case, and that's undefined slope or a vertical line. So if you have an undefined slope, you should have a line that just goes vertically straight up and down, and it should only cross the x-axis. It should never ever touch the y-axis. A vertical line has an undefined slope because for any 2 points, you would have to divide by 0. And as we've learned before, you cannot divide by 0. So we're also going to talk about parallel lines, and the word parallel means that two lines in a plane run the same direction and they do not intersect. Two lines are parallel if and only if they have the same slope, and they do have to have a different y-intercept. So only if the slope of one line is equal to the slope of a second are they parallel. Perpendicular. Perpendicular are two lines in a plane that intersect and form a right angle. And two lines are perpendicular if and only if their slopes are opposite and opposite means you change the sign, and then reciprocals, and that's where we said A would become 1 over A. A couple of examples. Are these lines parallel, perpendicular, or neither? So for part A, line 1 passes through the points 2, 3, and 4, 6. So you can label them x1, y1, x2, y2, and then you can plug it into our slope formula. So we have m equals 6 minus 3 over 4 minus 2. Again, simplify both the numerator and denominator. 3 over 2, and 3 over 2 can't be simplified anymore, so just leave it. Let's find the slope of line 2. So we have m equals 1 minus negative 5. Negative 3 minus negative 7. And then when we subtract negatives, we're really adding. So we should get 6 over 4, which at first doesn't look like either, but both 6 and 4 can be divided by 2, so you want to reduce. And then we should get 3 over 2. So because these two lines have the same slope, they are parallel. So let's try another set of points. For example B, we have that line 1 passes through 4, negative 1, and 5, negative 3. Plug it in. I changed it to plus 1 because we're subtracting a negative. Negative 3 plus 1, we get negative 2. 5 minus 4 is 1, so we have a slope of negative 2. And you can leave it for now as negative 2 over 1 if that makes it easier, but it does simplify to negative 2. For the second line, it passes through 4, 3, and 14, 8. Plug it in. Eight minus 3 over 14 minus 4. We simplify to 5 over 10, which again doesn't look like either right now, but remember 5 and 10 can both be divided by 5. So you always want to reduce if you can. We have a slope of 1 over 2. So if you look back to the definition of reciprocal, it means the slopes, or sorry, the slope of perpendicular, it means the slope are opposite and reciprocal. So for the first line, we have a negative slope. Line 2, we have positive, so the opposite condition was met. And then the reciprocal, A becomes 1 over A, so all we have to do is flip it, and that's exactly what we had happen here. Negative 2 became positive 1 over 2. So these lines are perpendicular. Because they have opposite reciprocal slopes. right, that is all for lesson 2.2. So if you have any questions, let us know.